Hello everyone, today I'll be showing you how to make a planetary orbital movement system. It can be used to make a solar system as you see on screen, or mini dioramas and things for your game. It's pretty basic, it's not elliptical movement, it's just circular. Yeah, let's get started. First thing we'll need is a new blueprint class of type actor. We'll call it BP_planet. And we'll open it up. First thing we'll do is add some components. We're going to need a sphere mesh, and we will need a spring arm. And last we'll need a rotating movement component. Rotating movement. We will parent the sphere to the spring arm, and this will give us our orbit distance. So we need to modify the spring arm just a little bit. We'll turn off the collision testing, and by default we'll set its target arm length to 0. For the rotating movement, we will take the Z rotation rate, and we'll take that down to about 20. 180 is a bit too fast for our use here. Alright, next thing we'll need to do is create some variables. Since our whole system is going to rely on parenting one planet to the next in a chain, we'll first need to define a parent. So we'll say parent planet. Make that public and make its type BP planet. And make an object reference. Next thing we'll need is to define the orbit distance. So we'll say distance to parent. And we'll make that a float. We want to be able to create some moons, for different effects. So we'll need to affect the scale of our mesh. So we'll say planet scale. And we will make this a vector 3. And since we want to have our planet, not all planets rotate or orbit at the same speed, so we're going to want to change our rotation rate depending on, for each planet, basically. So we'll create a new variable, rotation rate. And we'll make this a rotator. I think that's all we need for now. So let's get started on our script. First thing we need to do is get our parent. And we're going to want to attach our actor to its parent. So we'll do a attach to component. This will allow us to attach the current actor to the parent's mesh. So we'll just search for its sphere. Get sphere. And attach it to parent. Compile. And we need to set its location to snap to target. And rotation, we need to keep world, and scale will keep world. And that should allow us to make a nice hierarchy, basically. Next thing we'll need to do is our distance. So let's get our spring arm, and we will say set target arm length. Set target arm length, and distance to planet will be the value going in. And with just those set up, we should be able to test it. So let's drag a planet into our level, and no parent, distance to parent 0. Planet scale, we need to initialize that before we do anything. So we'll hop back into our blueprint here, and we'll set its default value. Say 1s across the board. Compile. Go back to our level. Let's set planet scale to 1 now. Rotation rate we haven't used yet, so we don't need to set that yet. And we'll drag out a second planet. This time we'll set its parent to our first planet, which will snap it to it. We just need to change the distance to the parent, and it snaps out. Now if we hit play, we should see our one planet revolving around the other. And if we take our second planet and we copy it, Now we can set its parent to be planet 2. This will basically give us a moon. Set scale to 0.5. And yeah, distance to parent, we'll just say 100. I'm just realizing I didn't hook up the scale yet, so that's not going to change. Alright, so the next thing we will do is hook up the scale. Say planet scale, get. We'll also get our sphere. And we will say set scale, set world scale 3D. Connect in our planet scale and connect that to our graph here. Compile, save. And you can see it's already reflected for our little mini moon. And let's see if it's working correctly now. It is. Alright, now we can see that little moon going around our little planet. Alright, and since we want to change the rotation rate, make it a little more interesting, we'll get our rotation rate, get our rotating movement component, and we will set rotation rate. Set rotation rate, connect up our variable, and connect it to our system here now. Alright, and we also want to set the default value at this point too, so we'll just set that to 20. And now we can change our moon, set its rotation rate to say 50, and it should really haul around that planet now. Okay, so it's a bit faster, it's just not super quick, but it makes it more interesting. And while we're doing that, let's create a second moon, just so we can see the difference. So this should have the same parameters, so we'll change that up a little bit. And we'll change this one's rate to, say, 150. And set its scale to 0.2. Alright. Now you can see we have a really fast moon. Alright. You can basically continue doing that, indefinitely, and create as many moons as you wanted. As a last little thing to show you, I just wanted to show that you could actually take these planets, you put them on a slightly different rotation, and they'll actually orbit like that. So as you can see, the planet is now rotating in a different axis. Makes it a little bit more visually interesting. And you can also see that the planets are actually rotating a little bit in their own axis. But that could better be accomplished with a panning material. Well, I hope that helped you. Hope you enjoyed the tutorial, and thank you for watching.